Well, hello friends. Today we are going to make the speaker beep because when I hit backspace here in the terminal, I kind of want there to be some feedback that hey, you are at the start of the line, right? So I'm sure that's going to get annoying in the long run, but right now I'm going to use this as an excuse to implement beeping. So let's just start by making the system beep right on startup, just so we know that we're getting beeping right. Here in init in the kernel, this is where we land right after boot. Actually, let me show you how that works. So this is the actual thing where we land after boot. It's a short assembly function that just sets up a stack and then calls into init. And then we end up here. And the first thing that we're gonna do is have a beep on and a beep off. And we'll just call beep on and beep off, and then we can just hang the system because we should have beeped by now, and then I guess we should beep for some time actually. So we beep for that long, I guess. Okay. This is a bit ugly, but we're just doing a little hack here. And then the way that you beep is that you use the interrupt timer has a dedicated timer channel, I think it's called, that is directly hooked up to this PC speaker, and it drives the speaker through that channel. And we are just going to program the timer so that it runs at a frequency that will generate the right tone that we want. So let's see, so we already have some timer setup code here. This is the timer that drives the scheduler in Serenity. And we're gonna do sort of the same setup, except for our different channels. We're gonna use timer 2. The scheduler uses timer 0. So first thing we're gonna do is just move this out of the CPP file so that we can use it from another source code file that we will create now called devices PC speaker, and also CPP. Okay, and then let me just refresh my Qt Creator. Okay, so in PC speaker we'll do pragma once, learn class PC speaker. Let's just make static functions for now. So we'll say like static void beep, or let's call it tone on, int frequency, maybe default to a clear A, and of course tone off. I think that will be a decent enough API to begin with. Okay, and then let's implement those. So let's see, wait, what am I doing? Kernel devices, PC speaker. And this PC speaker, okay. Right, and then let me grab that timer code that we had. So we're gonna, oh wait, this doesn't make sense. We're gonna include the existing timer header here, and then we'll probably, all we need to do is, well, it's not all we need to do, but the first thing we need to do is to do an initialization where we tell them this is the programmable interrupt timer control register, and we tell it, we select timer 2, and then we are going to write a word to it, which means that we're going to write not just 1 byte of the reload value, but we're going to write the whole reload value. So this is like an ancient interface here from way back in the day. So It's like has a special mode for writing a whole 16 bits to it. And then we're gonna put that timer 2 into a square wave mode, basically the signal generation mode. And then here, this looks a bit silly. Let's just do it that way. This is the part where we have to compute the reload value. So the way that the timer works in the PC is that it counts down from a certain value and one step at a time, and when it reaches 0, then the event triggers, whatever the event is, whether it's an interrupt or like changing the speaker from on to off or whatever. And then the reload value here is once again reloaded into the timer counter, and then it starts over decrementing again down to 0. So what we do is, so we have the base frequency of the clock of the timer chip, and this is that, and what we do here is we just divide by the frequency, and that will give us the appropriate value to reload to achieve the frequency that we want. And this is of course in hertz. Okay, and then we are going to send the to timer 2, we're going to send the reload value. We need that, yeah. We send it 1 byte at a time, so least significant byte comes first. And then I think there's one more thing you have to do. So you have to turn on the speaker thing. I think that's port 61, the lowest 2-bit of port 61. So that would be like we just take what's in there now, and then we OR in the bottom 2 bits. And then when we want to turn it off, then we just AND off. What am I doing? The bottom 2 bits. I think that's it. Yeah. Okay. So let's go in init, and here we can just say PC speaker tone on. Let's say 440. Tone off. Okay. Oh, we gotta include that. PC speaker. It's a private member. Well, I'm sorry. Okay, let's build it. Oh, shit. Forgot to add it to the kernel build system. PC speaker.o. Okay. Cool, it built. Let's see if it works. Oops. And nothing. Because speaker. PC speaker. Okay. So we just need how was it sound of a PC speak. Okay. Oh, you could barely hear that. Yeah. Okay. Cool. So we got a tone, and let's try a slightly higher tone. Nice. Okay. Then we know that that works. We can get rid of this stuff and do something a little bit more sophisticated. So let's add a syscall for this. And we can have a simple one just called like beep, I guess. It's a pretty good name for that. And when you call beep, what we're going to do is, actually I'm going to put this at the top. I never put anything at the top, and this one I'm gonna put at the top. SC beep. What we're gonna do for that is we're gonna, someone is gonna beep for us. Because we can't just do this, right? Because then nobody will turn the tone off and we'll just be beeping forever. So the most straightforward way to have someone turn it off, I guess, is to have the scheduler turn it off eventually, because the scheduler will always wake up anyway 1,000 times a second, so he can take care of this. So why don't we do something like scheduler beep? Then let scheduler deal with this. So let's add a function here, beep. Okay, and let's implement this somehow. So scheduler beep. Well, what we currently have is we have this thing here, guptime. It's a 64-bit keyword, which is incremented whenever the timer 0 fires, so 1,000 times per second. So we can use that as the timeout thingy. So we'll do something like keyword, can be static keyword as beep timeout, and we'll say that PC speaker tone on, devices PC speaker, say tone on, and then also that beep timeout is current uptime plus 140 milliseconds. It's a great number from the place where numbers come from. And maybe that's all that we need to do. Let's say 440 here. Having a default value is kind of silly, so let's do this. And then yeah, clients decide. Okay. So beep here, and then in scheduler, I guess in timer tick, we can do if there is a beep timeout in effect and guptime is greater than beep timeout, then PC speaker tone off, and beep timeout is 0. Okay, great. Let's add a syscall to userland so it can actually call this thing. So let's just do void beep in UniSTD because I put everything in UniSTD. And this will be really simple. It will just be syscall sc beep. Okay, and then it goes here. Scheduler beep, tone on, beep timeout, and the timer tick will turn it off. Okay. Cool. Then we gotta go in the shell so that when you try to backspace, so where's the shell? Shell main of the shell program is up here. Okay, so the main loop of the shell is here. And we just call editor getLine, and then we run the command. So let's go in getLine. And here we read keyboard input. Here we process the keyboard input. 1 character at a time. Okay. This is the line editing stuff. Okay, here's the tab, and here is backspace. Okay, so if the character is 8, or it's the term IO's be erased character, then we do backspace. So here is where we end up. I wonder why this is implemented this way. Oh, I guess we call it from manipulates. Okay. So I guess this part here, if mCursor is 0, then we're already at the start of the line. So it's a no-op, but now it's going to be a no-op that says beep. So we'll just print out an alarm character, a bell character, and flush. List it out. Because we're not going to have the shell do the beeping. That would be weird. We're gonna, because I mean, imagine if someone like remotely connects to your machine and he's using a shell remotely, and then your machine locally is like sitting there beeping because of the remote user. That would be weird. So we're just gonna print out the bell character, and then in the terminal on char we have this. Yeah, so fix me, bell. This is where we're just gonna beep when we get this character in the input stream. Okay. Now, did I do everything correctly? Let's find out. This goes here. This goes here. This goes here. I have a good feeling about it, but I do get overconfident sometimes. Wonder if the tone is gonna feel right. Probably. We already heard it, but I guess the length is also interesting. It might be a bit too short. I don't know. I'm just thinking of things to say while waiting for the build. Okay, there we go. Let me press backspace and yes, that's kind of nice. Did I like the other A better? No, definitely not. Yeah, 440. 440 is cool. Let's make it a tad bit shorter though. Try even a little bit shorter. Cool. I think that's pretty good. Okay, so let's do a patch review. And we changed a whole bunch of stuff. I guess we can do, well, let's just do everything in one go. So first we gotta add the PC speaker, and was there something else? No, okay. So in the terminal, we now beep when we get the alarm character. It's fine. And then PC speaker device in the kernel. Of course, this thing we could expand on this and give it more capabilities, but just for starters, we will have tone on and tone off. And we select timer 2, write the whole word, square wave mode, load the frequency into the timer register, and then enable the PC speaker. And then in tone off, we just disable the PC speaker. That's cool. Here's the little header for that, and adding it to the make file. Okay. And in the scheduler, we add the beep timeout. Then scheduler beep will turn on the speaker with 440 Hertz and set a beep timeout 100 milliseconds in the future. And then in scheduler timer tick, which will be called 1,000 times per second, if there is a beep timeout and we are past the beep timeout, then we will turn the speaker off and clear the beep timeout. Okay. And then here is just a declaration for our scheduler beep. Okay, so then in syscalls, we're adding the beep syscall to the list, and then we dispatch it by calling scheduler beep. That's straightforward. And then here we were taking these handy macros from the programmable interrupt timer CPP file and moving them to the H file just so that we can access them from the PC speaker CPP file. And then here in init we have an unnecessary change. So let me just get rid of that. And in the run file, let's go ahead and do this for every version of the run command, because I have a few different ones depending on what kind of networking you want, and they should all have the PC speaker enabled. So now they have that. Okay, and then in libc, the beep syscall is just a wrapper around syscall beep. Adding that here to the header, right? Finally, in the shell, the line editing code, when we do a backspace and we are at cursor position 0, then we will print out an alarm or bell character causing the beep. Cool. Very cool. Let me just see that I got this part right. Yeah, that looks good. Very cool. So let's commit and say kernel plus kernel plus others plus kernel, whatever, it doesn't matter so much. Kernel add beep syscall that beeps the PC speaker. Look this up. In terminal so that a character generates a beep. Finally, init is it or no, I guess like that. In the shell line editing code when backspacing at the start of the line. Cool. Great. Let's try it one more time. Very nice. All right. So I think that'll be it for today's video. So if you made it this far, then I thank you for watching and for coming back, and I hope to see you next time.